Okay, let's say you plug in your raw data and it looks something like this. Height and time is what you have. And I should really make this initial height, and that is measured in meters. So I put that there. And then if I double click on this line between A and B, then it automatically justifies the width of the column. And maybe I want to make these centered. So I click this. Now, all of these heights were measured with a meter stick whose precision was 0.1 centimeters. And whoops, these are centimeters, not meters, so I change it. So if the precision of the meter stick for all of these measurements was 0.1, that means we were continuously estimating one additional place beyond that. Now, it just so happens that my estimate was that this value was 20.00. Right? But maybe I was off. Maybe it was actually, maybe the height that I had measured off with the tape was actually 20.01 centimeters. Right? So there's some uncertainty in this, which we take as plus or minus 0.05 centimeters. But the point remains that these all need two decimal places beyond what's shown. So you can come up here and you can click left, left, and it just adds all of those decimal places under number. Or if you don't have that option, or you have a Mac, you can right click, or you can press Control 1 or Apple 1 and then do Format Cells. That brings up this box. You choose Number under the tabs, then Number, and then choose how many decimal places. Here are my time values, and let me capitalize T for time, and that's measured in seconds. And look at this, I forgot to add in my uncertainty. So I'm going to hit space, insert symbol. I have to find the plus or minus button. So if you're at the very, very top of this symbol chart, click it once, and then the plus or minus is the third down on the far left. Plus or minus, what was my uncertainty? Well, let's say I measured, let's say I did my uncertainty trials, and I found that my uncertainty was plus or minus, oh wait, this is my height. So the uncertainty in the height is simply what we had just said, 0.05 centimeters. Now I could double click and justify, or what might look nicer is if I go to Home, you can click Wrap Text, and then if I bring this over, and then I double click the line between 1 and 2, now it puts the remaining text on the second line. So I can center, center, maybe give a little more space here. And this is starting to look nice. Here I want to center my time. I'm going to do the same thing, wrap text, and then I'm going to add my uncertainty in time. And this is the uncertainty that I calculated using the half-range method. So let's say I estimate, using the half-range method, my uncertainty to be, 0.05 seconds, like this. Okay, and maybe we want to put a little space between the units. Okay, and again, let's center, so this is all the same. Now, the next thing we need is displacement. And we've all done this already. This is in meters, right? Displacement. And it's going to be equal to, it's this value, but it has to be negative, and it has to be converted to meters. So I do negative A2 over 100, and then I can just copy this all the way down. Center, center. And how many sig figs should this have? Well, this number has, it has 4 sig figs, right? This one has 5, but I'm just going to, for consistency, give these all, I'm going to give this 4 sig figs, and then make sure that these are all rounded to the same place. And what you see is now, this has 4 sig figs, this does too. This has 5, so does this. Right? Last thing I need is time squared. And the units there are seconds squared. So you can create a superscript by highlighting the 2, click on this arrow next to font, and then choose superscript, seconds squared. And I'm going to center. So this is my time times itself, and I carry this all the way down through. Each of these has 2 sig figs, so I'm going to go ahead and round this so that the least number of sig figs in any measurement is 2. This has 2. These have 3 sig figs, but that's okay, because really what we care about is that these all have the same decimal place, the same precision. And that's achieved when we give this one 2 sig figs, and then we round these to the same place. Okay, we can create some border columns, some borders if we'd like. So outside border, here we go. One more. And then I'm going to right click on the A and hit insert so that I can see my borders. Insert by right clicking on one. Okay, this is starting to look nice, like a good graph. Next we insert a scatter plot. So you go to insert, scatter, and you choose the option with no lines. We don't want any lines or anything like that. Maybe you see a bunch of weird things in your plot when you insert. Maybe you see an empty plot like this. Either way, you click select data. So this is under the design. If you click off of your chart, then the design tools disappear. The chart tools disappear. So you click on the chart, here they are, then you click design, select data. You add a new series, and if there's other series already here filled in, just highlight and remove each one. But I'm going to add a new one. The x values should be, well, for my first chart, I'm going to put my independent variable on the x, and I'm going to put the dependent variable on the y. And I hit OK. I'm going to delete the legend because I don't need it. You go to layout, you can add a chart title, above chart, axis titles. These are expected, right? Horizontal. Maybe you want to do a rotated axis title on the Y. So let's see, where are we? Axis titles, rotated. And I'm not going to fill these in. You guys know how to do that. You have to make sure you have the appropriate units and an appropriate title. Then you have to make a second chart, and watch this cool trick. If you click here on the white space up here, not on your chart because that'll create problems, but up here, click, and I'm holding down with my mouse. Now I'm pressing Control, and if I, whoops, come back over here. If I let go while holding Control, it makes a copy of the chart. You might think, okay, easy enough, but adding charts aren't so hard. Well, here's why this is super useful. If you come over and click on a data point, it highlights them all. Click again, and now we have just one highlighted. Now you can move these little boxes around. And that's important because blue is the y-axis, purple is the x-axis. So if I click, so I get the 4-arrow icon that you see there. If I click and drag with that 4-arrow icon appearing, now I can move what my x values and y values are. So I want my y values to be displacement, and my x values should be time squared. And now this is what I have. Okay? You have to change your axis titles and your chart title for the second graph. Next, you right-click on a data point, click Add Trend Line. Right? We want it to be linear. We want to show the equation on chart. You can also display the r-squared value if you'd like. That's fine. The r-squared value is basically, it tells you how good your line fits the data. More precisely, it tells you how well does a particular x value predict a y value within your data set. But you can think of it as a measure of how good our line of best fit, actually how well it fits the data. So here's my equation, here's my r-squared value. The r-squared value of 1 means your data perfectly fits the line. So this is clearly a very good r-squared value, and obviously I've cheated in making my numbers so that I came out with a good value. Okay, this equation has the form y equals mx plus b. So m is this, negative 4.7628. Right, that's my slope. I get my experimental acceleration due to gravity by multiplying that slope by 2. But that's not enough. I need to know the uncertainty, so I go to data, I do data analysis. If you don't have that data analysis toolbar, you click File, Options, then you click Add-ins, and it's slow. Then you highlight Analysis Toolpack. You don't hit OK, you hit Go. Then you check this first box, you hit OK, and now that data analysis box appears, or the button appears. So you click it, you go down to Regression, hit OK. You choose your y and x ranges. Notice they're flipped here from where they were before when you chose your chart ranges. So y is first, and I want to perform my regression analysis on the second data set that I've evaluated. Right? I want to consider this data. where displacement is y and time squared is x. I want to choose new worksheet, or I could choose output range. And if I choose output range, I just want to say, okay, put my output right here, and then I'll have it here in my same chart. So I hit OK, and then it spits it out exactly where I told it to. These are the important values. This first one is my slope, and this one is the uncertainty in my slope. Right? This is the standard deviation. They call it standard error. There's a slight difference between the two, but we're not going to really worry about that right now. Okay. This times 2 gives me my experimental acceleration due to gravity. This times 2 gives me the uncertainty in my experimental acceleration due to gravity. Right? Now I always round my absolute uncertainty to 1 sig fig, so that becomes 0.2. This I round to the same place as my uncertainty, so that becomes negative 9.5. Right? So what's the range of my experimental value? Right? What's the range? Well, it's negative 9.5 plus 0.2 to negative 9.5 minus 0.2. In other words, that's the maximum, the minimum, since it's negative, experimental acceleration due to gravity that I've come up with. And then this plus my uncertainty, that's the maximum experimental acceleration due to gravity. So this is the range of my experimental acceleration due to gravity when the uncertainty is accounted for. Does negative 9.81 meters per second squared, the accepted value, does it fall within this range? No, it does not. It barely lies outside. So I've got a decent value, and I'm going to have a small percent error, which you have the equation. You have the equation for calculating that. But I still have this problem, which is that my data doesn't agree with the accepted value. My experimental results do not agree with the accepted value. So I would want to discuss this in my lab report. Maybe I was doing something wrong. Maybe this uncertainty is an underestimate, and I should, have a higher uncertainty. So this is just food for thought. What I expect to see in your lab report, I want to see these 9 cells. I want to see this chart title. This chart with the appropriate titles. I want to see this chart with the appropriate titles. I want to see this data table showing your raw data. This should be a separate data table showing your processed data. And yes, that's going to be it from that's going to be what you paste into your report from Excel. Right. Let's see here. What else? There's one last thing. Let's say you have data that looks like this, right? So I'm going to cheat, and I'm going to copy this. I'm going to copy, what am I going to copy? These cells over here, and paste, and yes, good. So let's say you have this data instead of the nice pretty data that I showed in my first example, right? And let's get these nice pretty headers in. Very good. And let me show you what this looks like when we graph it. It looks something a little uglier than what we saw before. We insert a graph, scatter. Oh, look, all those weird things. Select data, get rid of these. Add. The x values, again, I'm going to skip my first graph and cut straight to the second graph. So the x values are time squared, and these are my y values. Look, I have 2 different trends occurring. So if I add a trend line, it's not going to look very good, right? Because it doesn't really fit either of these 2 data sets. If you see something like this in your data, here's what I want you to do. I want you to make a copy of this down here. Then I want you to get rid of these these other trials, right? And analyze only some of your data. So let's see what this looks like if I get rid of these other trials so that I can see just the limited trend. Well, now it doesn't look so bad. Oh, let me bring this back up. Right? Negative 4.1399. That's not so bad. So what I would expect is for you to identify by trial number which you followed up with, which you looked at in a follow-up analysis, and then present this new acceleration due to gravity based on your limited data set.